This is 1.4, combination of functions. So we've been talking about functions and their behaviors. We've done a couple of things by evaluating functions. So now what we're going to do is combine functions together. So here's a couple of notation things. So whenever you see this f plus g of x plus f plus g of x, that just means that you're just adding the two functions together. So f of x plus g of x. Whenever you have this type of notation, when there's a minus, that means you're just subtracting the functions from each other. This just means multiplication of the two functions. And then finally, this just means division of the two functions. Now, this you have to be provided that g of x is not equal to 0. Now, typically what we're going to be doing with these combination of function or with these function combinations is that you're going to be asked to find the domain. So the domain here, and it kind of makes sense, is that the domain is the intersection of the of both the domains of f of x and g of x. Okay, so the domain is just basically of this entire combination of functions is just the intersection of the domains of f of x and g of x. Now, the only one that you have to be very, very careful with is this guy, the division, because you have to check the denominator. The denominator cannot be 0, so you have to really check that guy. Okay, so why don't we do a couple of examples to kind of get us in the right mindset. So what you want to do is, given f of x equals x squared plus 2x and g of x equals 2 minus x squared. And what you want to do is find f plus g of x, f minus g of x, f times g of x, and f divided by g of x. Then find the domains for each. Okay, so let's start off by figuring out each of them, and then we'll talk about the domains. So let's start off with f plus g of x. So that just basically means that we're adding up f of x and g of x. Okay, so this is going to be x squared plus 2x, and then we're going to add it to 2 minus x squared. You can see here that the x squares are going to go away, and all you're left with is 2x plus 2. So that's going to be my answer. Okay. Next, let's figure out what f minus g of x is. So remember that this just means it's going to be the function f of x subtracted to g of x. So you're going to have x squared plus 2x minus 2 minus x squared. I like writing them in parentheses because the common mistake here is that you sometimes tend to forget this negative. So you want to distribute that. So you have this x squared plus 2x minus 2 plus x squared. So notice here, these guys are not going to cancel out anymore. This is going to just give me 2x squared plus 2x minus 2. That's going to be that solution. Okay, so now what we're going to do is find what f times g of x is. That's just the multiplication of both of these two functions together. So you're going to have x squared plus 2x multiplied by 2 minus x squared. Okay, so let's FOIL this thing out. So this is going to give me 2x squared minus x to the 4th power plus 4x, and then minus, what is this, 2x cubed. Okay, so the way that I like to write it is I like to write them in um in order of decreasing. So x to the fourth goes first, then the 2 minus 2x cubed, then the positive 2x squared, and then the positive 4x. So I like to write them in decreasing of exponents. Okay, and now finally we're just gonna do f over g of x. So that is just the division between f of x and g of x. So f of x in this case is equal to x squared plus 2x, and then g of x is 2 minus x squared. Okay, here there really is not much that I can do, so I'm just going to leave it like that. Okay, so here in general, the domain for the first three are basically going to be the same. Now, the way that we find the domain is we got to look at f of x and we got to look at g of x. So f of x in this case, you can see that's just x squared plus 2x. G of x in this case is going to be 2 minus x squared. If you remember, these two are polynomials, which means that their domain is from negative infinity to positive infinity. So if I try to intersect both of these guys, well, they both have the same thing in common, so it's going to be negative infinity to positive infinity. That's just the answer, okay? So this combined with this gives me this, okay? So not that bad. So what this means is the domain for f plus g of x, f minus g of x, and f times g of x is all real numbers. From negative infinity to positive infinity. And you can see why, because if you see these answers are just polynomials, okay, which is all real numbers. The only one that's really odd is this guy, because when you divide things out, you get a denominator. And remember that for denominators, so f of g of x is equal to x squared plus 2x divided by 2 minus x squared. Remember that when we have something like that, we're going to take the denominator and we're going to set it equal to 0 and figure out what values it cannot be. So I'm going to subtract by 2. Negative x squared equals negative 2. Divide by this negative 1. So x squared equals positive 2. And then take the square root to both sides. And remember, when we take the square root, you add plus or minus. So x equals plus or minus square root of 2, which means that it cannot equal those two numbers. So for this guy, it can be every single number except negative square root of 2 and positive square root of 2. So it can be anything you want. It's still all real numbers except for those 2 points. So it'll be, remember, here's negative infinity. Here is positive infinity. So it'll be from negative infinity to negative square root of 2. And you're not including that. Then everything in between there. So between negative square root of 2 and square root of 2. And then from square root of 2 all the way to infinity. Okay, that's going to be the domain for this division. So when you have the division, you do have to work a little bit more. Okay. Okay, let's do one more example. So let's say you have f of x equals 1 over x minus 3 and g of x equals square root of x. Find the domain for f g of x. Okay. So in this case, notice that we have a multiplication of two functions, so you can multiply them if you want. So f of g of x is just basically 1 over x minus 3 times square root of x, which basically gives me square root of x over x minus 3. Okay, but we don't want that. What we really want is the domain of this function. So what you got to do is you got to think about 1 over x minus 3 and square root of x. So you got to look at those two. So let me write it like this. Square root of x on the bottom. So when we think about the domain of the first two, so we're going to try to look at the domains. So remember that the domain of this guy is basically taking the denominator and setting it equal to 0. So that means x cannot be 3. So it can be any number that you want, it just cannot be 3. So that's the domain of the first guy, okay, of f of x. Okay, now we got to figure out the domain of g of x. Remember that for the domain of g of x, we have a square root, it's even. So we're going to take the radicand and set it greater than or equal to 0. Okay, so notice there's not really nothing to solve. So here is 0. It's included, and it's everything that's positive or greater than that. So here is 0. Everything's over here. Okay, so the domain is going to be the intersection between these two different domains. Okay, so what you got to do is think about where do both of these guys have everything in common. So if we kind of think about starting from negative infinity all the way until 0, you can see that there's nothing in common. Okay, so nothing is in common right there, because they're not both matching. The first number that they end up matching is what? It's 0. 0 is the first number that both of these guys match. So 0 is the first candidate. It's the first value. Then afterwards, you can see that the next break is at 3. So at 3, you can see that everything is good until you get to the 3. And at the 3, this is not included. Okay, and then afterwards you can see that everything is really good. Okay, from 3 on, everything is great. So basically the domain is going to be this new guy, this guy. So what did I get? So nothing over here, it starts at 0, and I'm including the 0, and then I'm going to go all the way to 3 and not include the 3, then union with 3 all the way to infinity. And infinity, remember, it's not included. Okay, so that's basically how you find the domain. So you want to make sure that you find the domain of each of them, combine them together, okay, and then see where they're kind of overlapping and not overlapping.